Hi, everyone. Welcome to Project Pro's podcast on GenAI monetization, where we uncover enterprise use cases and implementations of GenAI. Today, we have with us Lohit. Lohit is actually the lead product manager for GenAI at Adobe, where over the last year and a half, he has taken live multiple GenAI projects across many Adobe platforms and demonstrated uplift in revenue and cost savings and customer engagement. Today, the focus of our conversation with Lohit is going to be text to image models. Welcome, Lohit.
Hey, thanks, Binny, and thanks for inviting me.
Great. So, Lohit, to begin with, it'll be helpful to understand in what kind of use cases do text to image models make more sense than the LLM models that we all kind of understand largely today?
So
Yeah.
that's a great question. So the most important part where we see a difference between a text to image model and the large language model only for text, right? They both are large language models. So some is a different modality, but they both are very big model in the size. They have millions of parameters and billions of parameters to actually understand the customer queries and answer something. The major difference is the text models in general do certain tasks, which is kind of like summarization and Q&A. But text to image model also go one level upper in the multimodality and also try to generate something useful or visual representation according to the described text. Which is kind of like a filling out the gap between the NLP and the computer vision, combining both of these together to understand the customer context and then finding out the right images.
Got it. Got it. That makes sense. And, could you help us understand how these text to image models actually translate textual descriptions into just visual representations?
Definitely. That's a great question. So, text to image model are a class of AI, or we can also call it like a generative model class.
Mhm.
And you would have heard about this that in the recent year they got a lot of attraction, because the main core of this model is that you can describe something in words, which is easier, and then the model will generate a representation of in terms of image, which can be very, very useful if you are trying to explain something to someone, or it has numerous scopes, right? And this model actually leveraged the power of deep learning to translate the human language into a visual representation. And that also bridged the gap between NLP and the computer vision. So let me give you like a little bit overview. So generating an image from text description, what there are a couple of processes involved in this. So I'm going to like define this into majorly three processes. The first step is that we need to train a pre-trained model, or which we call as CLIP. It's a contextual language image pre-training, right? So before training to a text image model, we pre-train a CLIP model to learn the relation between image and text. CLIP model consists a couple of components. First, we need a text encoder, a transformer-based architecture that can translate text into a numerical representation, or we call text embeddings. This text embedding actually captures the semantic and the context of the text. A second thing is we need is an image encoder. Image encoder is the translator which actually translate or create the image embeddings according to the text you mentioned. So these two components are very, very important in the CLIP model. Now the part where the CLIP model work is that the CLIP is actually is a trained on a large data set, and large data set consists image and text pairs. So what we are trying to do here is that we are trying to learn a mapping between these images and the text pairs. So the objective of the contrastive learning, the model is to train find a maximize the similarity between text image weddings and for the matching pairs, and while minimizing the similarity for non-matching pairs. So this is kind of like a core concept of contrastive learning. So that's the most important part is. Now we have the clip model. In the clip model, we have bunch of images, bunch of text. You put this inside the encoder. You put inside the text encoder, inside the image encoder. You combine them, and then we have a big clip model which understand that what text embedding represent what image embeddings. So in layman terms, so we have that exists with us. That's the first part. The second part is that now we need to train the actual model. So using the pre-trained clip model, we train the text to image model to translate text embedding into image embeddings. So for that, we also need like a one encoder, a text encoder. What will happen in that text encoder that you will ask a query or you will take a text, you pass the text into a pre-trained text encoder to generate a text embedding. Once we have the text embeddings, we will use it to find the corresponding image embedding from the clip model. Now we have an input and now we have an output, right? This is kind of like now I'm going to talk about the heart of this model, which is called off as a prior. So if you saw dall-e open source research paper, they talk about the prior. So the idea here is that what we are trying to do is here that we have a text embedding, we have a model in between that, and we have a output of image embeddings. So what we want to do this prior to learn that how to take a text embedding and generate the image embedding out of that text embedding. And this prior has like a couple of different ways to do this. Like we have a way to do GAN. You can also use diffusion models or you can use VAEs. All of that can be used. They have like their own pros and cons. So whatever suitable is for you, you can use that. But the main motive is to learn from the text embedding to the output of the image embedding. So what we do is that we keep on rotating or keep on doing the same process again and again, and we find out, okay, now like with millions of data set points or like large set of data points actually train this model. And once we do this process, we find out, okay, now our prior is trained to generate image embedding using text embedding. That's the second part of this, which is actually a code. Like this is a very, very important part because we never had this functionality before where we are converting this to different modalities. The step 3 is very simple. Like once we have these image embeddings, we can use image decoder to just decode that image embedding into a real image. Again, you can use GAN, you can use VAEs, you can also use Glide, right? Glide is also like a already existing model which can be used in the diffusion based model. So the idea is that once we have the image embedding, you use image embedding, pass through to a decoder, and decoder will generate a real image. Now, after that, you can also apply a couple of different things. That once you have the image, you can use SR GANs, which can actually make it better. It looks better because brighter. We try to increase the resolution of the image. So it's like a very high quality image, which is the important part. You can also do different post processing, right? So like you might want to resize it or add some colors or add some natural information so it makes more realistic. That can also done, like it depend upon your outcome, like what use case you're trying to solve. But this is the way, if you follow all of these steps, this is the way the overview of this text to image model works.
That is very well explained, Lohit. Thanks for that. I just have one follow-up question, which is in a regular language model, right? What the language model is trying to do is to predict the next most likely token. Is there a similar thing in the image model? Is there a concept of a token? If that's so, is the token a pixel or is it an image by itself? What is it predicting?
Great question. So that's the difference between the architectures, right? So what you ask is absolutely correct. So so the VAE actually follow the way what you explain, predicting the next pixel and try to understand.
Okay.
Diffusion model work in a different fashion. So diffusion model work is that you have diffusion model work that you have an image, you add a particular noise inside that image, and you keep on adding the noise until you get the finally like a very high noise image. and then you learn this noise every time what you are adding in terms of model. And you can use the uh, like a distribution, any distribution. Like again, Gaussian is very famous, but yeah, you can use different type of distribution to predict this what you are adding in terms of noise. Keep on adding and going to the last stage, and you reverse this process. So that's why we have a diffusion forward and backward, and that's the way the model learns that how do I generate an image with high noise, and that's the way the text embedding go inside the prior and try to see, oh, we have a text, we have a noisy image, we have a couple of other parameters, which asking me to generate the final image. So I can keep on adding something so I can reach to the final image. And they can keep on repeating it to understand what actual text represent in terms of the image. So this is the way it works. Like, this is the architecture type of information. Sometimes it's a next token, but in terms of images, it's not the next token. It's more about taking the text embedding and then using the right parameter to generate the final image. And the VAEs work in a different architecture, which has more like a encoder decoder base. So you have encoder and decoder. You take the text and then try to encode and then find the latent space. Once you find the latent space, you go to the decoder and then do the same things. Yeah, but yeah, theoretically it's very close, but in general, the way we are using different architectural work in a different fashion.
Noted. Noted. Could you maybe help us understand this more practically by helping us walk through kind of a real world example with some KPIs associated with this, how a text to image model is providing value?
Definitely, yes. So yes, of course, everything has to be a real use case to actually deliver a lot of values. So 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 think about that. This is not limited to this particular use case, but think about the problem statement of e-commerce platforms, right? E-commerce platform, what they do that they often struggle with a good quality of images. They struggle that, okay, how do we find diverse images or high quality of images to represent something, right? And if they don't have the good quality of images to represent the products, there is a very high probability that the customer who are interacting with this all of those products will leave, right? So and also think about in terms of that how it's very helpful for the companies, because generating these images in the older fashion, if you think about it, is also resource intensive, right?
Yeah.
You first need to find out that, okay, what catalog you're trying to create. Then you need to hire a studio, hire a photographer, and then you ask them to generate those images, then ask them to edit and share with you,
Yeah.
right? So once you do all of this exercise, then only you can post all of this in on the website.
Mhm.
So just think about that, how it's very helpful for this bigger ecosystem, right? So I can take one example, like for example, Nike, right? Nike has so many shoes. They have so many colors of those shoes, so many sizes, and then it's also differentiated according to lot of patterns.
Mhm.
So think about that. If you are running that company and you want to launch a couple of different shoes in next 1 quarter,
Mhm.
then all of this exercise required to do same thing to launch this, and it can be very time taking and still not be very useful, because it's not about that you have a one image which is presenting the actual information about the product. You may need different angles. You need a different variation of the how they look like on someone's shoes, how they look like from the top, or sorry, someone's leg, or how they look like from top, bottom, sides. So many ways, right? And doing all of this requires so much time, and you cannot wait, right? This market trend walk or work so fast. So so you need to be ready to actually launch something, and waiting for this, it can actually delay the product launch and can also make in terms of like a loss for the company, right? So this is that's why it's very important, very important. I can take one more example. The second example is in things in terms of like designers, right? So editors. So if you're a designer and you want to design an interior, or you want to design a dress or something,
Mhm.
using this tool actually give you a canvas which is not blank. So
Mm.
you try to explain what you really want to start with, and then you write it, and you get an image which is not zero. and then you can start from there and reach to the final product, which will reduce the overall the scraping of all of this, right? So you don't need to be just brainstorming about this and starting from zero and scratch. Very, very helpful. Also think about in terms of 3D, right? 3D and VR products. With the 3D and VR products, the time is moving in a very, very like high pace. Virtual ons and virtual try-ons. If you see that Amazon actually already left release, eBay released it, so people can try the products, and they all need like a virtual environment to show all of this, and that's why we need all of these fast-moving models which can actually allow us to do all of these great things. That's why there is a very high demand of these models in the previous 1 year. If you see, there is a very, very high demand from different uh, bigger organizations spending millions of billions of dollars to just explore, understand this model, and launch like a bigger and bigger models.
Mhm. Got it. Got it. And the Nike use case that you mentioned, for example, let's take that use case. I have two follow-up questions. One is, how do they measure the success of something like that? Is it usually cost, time to make one image? Is that usually how business teams would think about it?
No. So yeah, that's a one side of it. But
Okay.
but I think if you think about measuring the overall success of this particular feature is not related to only one thing. The first thing is that you also need to think about the customer experience. That's very, very important.
Okay.
So think about that, how you represent the image, product's image,
Mhm.
and how a customer engage with it. It's very, very important.
Right.
The the image is or the way you represented your product in that image is very important, because customer first time whenever they are buying something online, they try to click on it and they will see it. If the quality of that image is not up to the mark, or if we do not have enough variation of that image,
Mhm.
then maybe the customer will lose the interest, right? Think about that. If you have one image for one shoes, maybe they will not even like try to buy it, because they will think, oh yeah, it makes sense for me, but I'm not like fan of it. I want like at least want to see from top, bottom, side, and stuff like that.
Yeah.
And if you think about it in terms of, even though a customer buy it, there is a probability that he may return or she may return in some time, because they thought, okay, yeah, I got this product, but the actual description or the image was not very well for me, because I wore it and it's looked like very small from the top, right?
Mhm.
So customer engagement is very important. You can track all of these things with different ways, right? You can build analytics pipelines around it. You can build CTR to conversion rates. So,
Mhm.
like you can measure the success like this. So
Yeah.
you take certain number of shoes and then you try to generate images as making them static in that variations. And you launch this and then you build the analytic pipeline around it. That how do I say the customer click on different images, how many times customer check all of those images,
Yeah.
how many customer click on different variation and bought the products. So
Mhm.
CTR rates is very, very helpful.
Mhm.
And you can also see that you can win the loyalty of the customer, right? So the return rates, customer
Yeah.
can actually happy with the customer engagement. They probably will come back. As they
Right.
come back, they will be like happy to see that, okay, how many times you show a different variation. And as you go on the try on mode, very, very helpful, because try-ons is the one more thing everyone is trying. That's very, very helpful. Operation cost, you mentioned, yes. Operation cost is one of the factor, yes, very, very important, because it reduces the overall launch time, which actually translate directly into money. And it also reduce the overhead of all of this external factors, which is nothing to do with Nike, right? So they are a product which are launching its shoes, but they
Yeah.
are stuck with the images, and then they still need to rely on the Photoshop, photo studios, their wait
Right.
time, editing, and all of those things,
Mhm.
right? So that's the operation cost. And you will also can also measure this is the active users. You can just compare a page which shows only a one image of a product versus like a five different variation. People engagement probably will be, or active engagement will be higher on the more variations, because everyone wants to see everything before they buy, right?
Mhm.
So that's the way you can measure the success criteria of these features when you launch on certain products.
That makes a lot of sense, which is rather than very specific tactical metrics, the more holistic customer engagement angle. Plus, for a company like Nike, it helps them focus on their core business of shoes and not, photographs and editing and things like that. That makes a lot of
Exactly,
sense.
exactly. Yeah,
Yeah.
because
I have
like
one more. Mhm.
they want to focus on the part where they are good, right?
Right.
Instead of overhead of these things.
Yeah. Yeah. And I have one follow up question on this, Lohit, which is, so now for a company again like Nike, for example, when they're going to implement a model like this, uh, in a in the world of text models, you take a foundation model and you either prompt tune it or fine tune it or use some RAG based approach to make it closer to your internal data set. Is there a similar concept in an image model? Is there something like, is there a fine tuning component there with your local data set? Does it make any difference?
Yes, yes, definitely. They have a, this is called like a customization of models, like what you mentioned. Yes.
Okay. Mhm.
So in the text to image model, they do have customizations.
Mhm.
Customization actually depends upon the use cases. So for
Mhm.
example, a lot of companies, like for example, Nike is kind of like a shoes company.
Yeah.
So adding a little bit bias related to shoes is going to help the model to generate a better images. That
Mhm.
totally makes sense. And the way we fine tune our model to understand these scenarios is actually very helpful. So the customization and the diversifying this, it's very, very important. And there is a in most of these model we have a layer, but I think most of the people trying to build a out of the box at the top of this customization. So you have a like a your own base model, and then you try to customize it at the top of it. But the customization should be according to the domain expertise. Uh, the part is that where the text model and the image model differentiate with this, the computation cost of a text model versus the image model is a very, very different. The text model still is not very, very expensive actually, because like it's a certain number of data set we have and then believable parameter. But image model computation is very, very high, because the way we are making our model to learn these representation from one representation to other representation, it's still in very, very, very high cost training mechanism. So they are very similar. Yes, we have way to fine tune it, but we want to actually think about that. How do we build a generic model first and then start adding these customized layer at the top of these models?
Makes sense. And what are some of the challenges you encounter on the ground when you implement these models, and how do you kind of overcome these?
Yep, there is a lot of challenges. Yes.
Mhm.
So I'm going to talk about like challenges, like what we actually face. And I'm going to talk about the strategy, what we in general follows to improvise it.
Mhm.
The first challenge, like which is the quality of the image, right? What you're generating. Very, very important, because if the quality of the model is not to the mark, the consumer will not be happy with this, and this product will be never be successful, right? So the idea is that how do we do it, right? So first thing is that okay, you take a very big data set, you try to train, and then you make some architectural changes in your model to understand it. That's the one way, right? But you also need like some human intervention to understand what we are doing good and what we are doing bad, right? So that's very, very important. And there are different research paper around this particular thing. We have a research paper which defines that okay, defining different tasks on different steps help us to understand the accuracy of the model. I'm going to just like give you one example of that.
Yeah.
So so every model should be able to generate a rectangle without no issue. That's a small level task. But you say okay, that the medium level task is that okay, every model should be able to generate a rectangle in a 3D format with someone standing next to it. So maybe this is the medium level of task you need to define to measure the accuracy of the model. And the third part is that okay, you have these two things, but they are all close uh, to a Statue of Liberty, right?
Mhm.
So all of these things fit together. So we define the small, medium, and large tasks to understand the accuracy of the model. This is the way you can actually overcome this challenge. This is one way. But there are a lot of research paper around it that how out the different cost function you can change, or the architecture improvement you can do. All of them are great. Some works very well, some works not very good. That's the thing. And the last part is like the human intervention, right? That's always helpful. So defining these tasks also help human to know what they are assessing and then give us a right feedback. Very, very important. So that's the one challenge, very, very important challenge. The second is the contextual accuracy. Very, very important too, again, because the text, what it representing in terms of image should match. If you
Right.
say generate a rectangle and it generate a circle,
Mhm.
like it's just misaligned. It of course it's not accurate, but it's just misalignment of this expectation. So so how do we overcome this? Is like building better training data set, right? So the way we are built, we talked about the clip model where we have a text and the images. They should be accurate at least. We should be accurate in terms of the annotations. The second thing is then also thinking about that better attention mechanisms, right? So in terms of, you think about the model terms, so better attention mechanism. There are a lot of research going on, like vision transformers and diffusion. All of those, like they have like a how do we build a better attention mechanism on the details, which is important, right? Instead of like worrying about the other things. So maybe when you mention a test which is explaining something, it's not accurate or it's not like well defined. How do we just think about it? Okay, which is the most important part of this text and why we need to be very accurate about those things, stuff like that. And again, human intervention, putting a human as a feedback loop, very, very important in the initial stages, which can help to actually train all of these models. That's the second challenge. I think there is a one more very, very important challenge is the ethical and the legal considerations.
Yeah.
So, well, so as these models are going live and they are larger and larger, and everyone, like, it's not about that everyone is using them in a good purpose, right? Sometimes it's they can ask anything and we can generate anything. So how do we find the potential ethical issues related to AI and do not generate which is illegal? Right. So implementing strategies around the prompt engineering, the concept why they came is it's like this, like understanding what we are training, but training will not actually help us to only like remove all of these things. So how do we uh, develop the copyright related issues, or how do we find the right guidelines in terms of policies and terms and conditions to understand, okay, what we are generating is makes sense because this is the relevant information for the customer, instead of like generating a harmful content, right? Harmful profane content is also not helpful, like, because we want to allow a lot of people like under teen customer also to use this, right, in the education or any other field. So very, very important. Legal and ethical consideration is very important, very important.
Makes
And
sense.
also one more part is that how do we integrate this with our existing infrastructure, right? That also very, very important, because you need to find out the right business use case and then you need to like make this available for that particular use case. So there are a lot of different uh, things you need to do when you're onboarding customers, right? So enterprise customer also required to make certain number of changes in their also ecosystem to just directly onboard it. We can onboard this as a API level, which is like microservices, and they can directly consume it. But after consuming, they still need to do something with it. So how they do it, right? So making this end-to-end pipeline for consumption is very important. So how do we like build a ecosystem which can directly generate 10 different variation of these products, and then consumer can easily consume it and then deploy it directly to the websites, right? So finding that right workflow is very important.
Got it.
So I think, yeah, these are like I feel like the major concern. There are one more concern which I feel like the resource and expertise requirement, but I think with the new trend, this is kind of like a constant right now. Like
Right.
different research going on, and there are a lot of things happening. So finding right expertise is hard. So
Mhm.
that's still existing issue.
Okay. And, to the extent possible, without going into confidential stuff, Lohit, could you help us understand what a deployment implementation looks like for a GenAI project in text to image? How do you choose the right model and the tech stack and things like that?
So basically, I think the right tech stack versus like how do we deploy this model. So in general, I feel like the overall microservices and the container mechanism is the optimal way to go with this.
Mhm.
So building a service which can actually take a text as an input and send a response back in terms of image or videos, right? Like it's not only one or 3D format, whatever we are looking for. So the idea is that if you are integrating this with a bigger ecosystem, you need a cloud-based architecture which can allow you to generate different containers according to different model versions. Because sometimes we don't need to change all the model for everyone because we may have like 100 clients and all of those 100 clients does not require updates on their model because all of these models are very expensive. It's because you need to use a very high computational power to train all of these models. And as you use all of this energy and power and it cost in terms of money. So the way it is that it has to be an independent deployment according to the model versions and the service integrations. You can use Google AWS and all of those things. That's like pretty standard in the market. The most important, like backend and front end, I'm not going to talk about this because that's depend upon the people who like which type of backend and front end services. That's like straightforward. The model part is right. I can discuss a little bit in depth in terms of models. So there are a couple of different model exist in in right now in the market, right? So we have a dall-e, we have Imagine, we have Firefly, and Google Gemini is also like one of the models. So all of these are like a great models because they have millions and billions of parameters they are trained on. They are very efficient to generate images and they give you like really nice realistic images. But they all actually also differentiate from each other in certain ways. So for example, just think about the way you generate an image using a diffusion model may be different than when you generate an image using a VAEs. I think Gemini is more close, like they are using VAEs, and I think dall-e is using diffusion models. So there is like kind of like a very own preferences between the different places because they use different type of data sets inside because they have bigger data, like a different variation of data sets, and that's why this model varies from with each other. Sometimes people also use VAs. So it depends, right? It depends upon the way you collected the right training data set and how do you want to use that training data set to train your models. I will give you one example of that is that VAEs require extra number of data points, a more data points to train the similar type of accuracy what a diffusion can get. But again, this is also very domain based. Sometimes it can be reversed, but what I understood from a lot of research paper and a lot of videos that the way these technique was, VAE requires more uh, data points than diffusion model. Also, I can also talk about the GANs. So GANs also is like they have like one existing problem. So GAN generator, sorry, yeah. So they have discriminator and generator, and the way they work is the discriminator actually is trained to discriminate what is real and fake, and generator is trained on generating images. So how they work is they start generator start generating images, and discriminator says, oh, okay, this is real or this is fake, this is real and this is fake, and then they keep on using these losses in terms of retraining those models. So the generator can generate a better image, and discriminator can discriminate between real and fake. So they get both better, but at some point of time they both reach very close to each other and they don't know if it's a good image or bad image. So there are a couple of ways you can compare the model according to your use case, what you're trying to build, but it's very dependent on like what use case you're trying to solve. Sometimes for you it could be possible that the accuracy of the image in terms of quality is not very important than the size of the image, right? So it depends, right? So that's my point. Is like we have a couple of different models exist in the market, a couple of different open source. I think they're also coming. But using them according to the use case is very important.
And for companies who want to go down this path of text to image models, what recommendations or guidance for best practices and hurdles to avoid do you have for them?
So I think recommendation for business, like what they are doing and integrating these models, are first you need to think about that what business case you're trying to solve. That's a very very important part. Like determining specific area where this model can be very valuable. Like for example, it can be maybe like for example we discuss about the e-commerce, but can we use this for marketing, or can we also use for customer engagement, or can we also use to creating like a proper movies, like animation movies and stuff like that. So identifying right business use case is very important. So once you have the right business use case, you define that how we are using this and improving the customer productivity or customer engagement or ARR or growth. So all of this is very important. So if you do not have this, these are expensive models. So if you don't have this, then you don't have the value. And if you don't have the value, then using this model will not give you anything. Second thing is that I think the quality and the data is very, very important. Everyone should know that, okay, what type of data they want to train their model on. If it's something domain specific and you want to restrict it, then you need to collect that type of data and start training it. Also, diversity is very important, right? If in different cases, if you are using image text to image model to generate different peoples, like different ethnicity, or if you want to go to a wider range of generating images which can cover a lot of things, that's very important. Quality is also very important. If you think about it, that the way it generate the image, the quality has to be really good, because the quality is not good, then there's no value of that image and it's just waste of effort. The same way, the way it represents the text is also important. So if the text has to be accurate according to the image, if it's different, then again they have no value. Uh, I think ethical also is very important. I think that's like for every company, they need to follow the right guidelines to allow this model to generate things. And I don't know, like again, these are AI guidelines. Everyone should follow it. It's very very important. So it's kind of like using right guidelines help to control without just like going in a haystack, right?
Mhm.
Uh, and also like maybe uh, investing on the right businesses, like right technologies, because I think right now it's very very expensive. So finding out the right hardware or algorithm which takes less energy and less computation cost to generate this model, very very important.
And as you kind of look towards the future of text to image models and what's coming up and the advancements, what are you kind of hopeful for and what do you expect to see coming up in the next few years?
So I think according to me, I think this is like a starting points what we are living in text to image model. Just think about that. There are like a huge application of this. Uh, like for example, simulations, right? So all the automated uh, homes, smart cars, automated cars, or all of those things require a lot of data. Providing this data can help them to actually pan out these journeys and then add different variation of these journeys to make those systems very successful. So think about this is the one way. The second way is also, instead of doing research, we can also have computation before the research. For example, launch of a rocket, right? Cost a lot of billions of millions of dollars. So can we just build a simulation which can actually test this theory before we launch it? So can we build this images structure which can be used directly to actually do all of this? How do we uh, improvise the try-ons, right? How do we improvise the 3D or VR quality or VR data, right? All of this require data. So all of these new tech or new features what different companies are launching, they need immense amount of data, and using this model actually help us to reach there, because it's not just asking someone's copyrighted image. It's actually generating a new image we don't know about
Yeah.
and helping them to actually train this model to fasten the process. So that's like amazing, right? That's amazing. And with the time, the usage of this is like again already started going with the multimodality. Recently, Google's multimodal assistant, that's super intelligent. You can actually take the camera and ask about the different thing what you can see in that camera, that can explain the code and camera products on the camera what you see. Amazing, right? So all of these multimodality actually was trained on all of these type of models to understand what you can see and identifying the right object, explaining the right object. So with the time, this the usage of these models going to grow, and slowly they will actually help in a lot of automation around us. It will
Makes
also
sense.
improve productivity, actually.
Mhm. Got it. And just one final question is, in your role, which is, it's such a cool role, right? Gen AI product manager at Adobe. What does a PM at Gen AI, what does that role look like? What are some of the hard choices that you have to make?
Sure. I think that's a cool name too. But yeah. So as a product manager, you have a lot of trade-offs you need to do whenever you are actually launching a product. So as a product manager, first you need to find the right customer experience. You need to work with different stakeholders to understand what's the value you can provide with this change. And then you need to define the research roadmap to understand, okay, when we can actually deliver it. Because all of these is, of course, very fast pacing environment. You need to understand end to end what you are trying to do in terms of business solution. Mm. And as a product manager, you're responsible from starting from zero, putting the stepping stone, working with a lot of different teams and a lot of super intelligent product managers, stakeholders, engineers, machine learning engineers to understand what we are trying to deliver it, and then actually define the criteria that okay, what is successful in term when we launch in the market. So the product manager actually own the roadmap of all of these products to go in live and be responsible for them to make successful in the live environments, help the customer and help them to onboard on the new technologies, because the product manager is always customer centric. According to the customer pain points, you try to build something which can help our customer to do something great, help them to optimize their operations, help them to optimize their creativity, give them like a canva where they can start something great, and they can actually like make a great art or designs, or improve the productivity of their overall workflows and stuff like that. So again, yeah, this is great to work as a product manager, to work with super intelligent people.
That is very exciting, Lohit. Thank you so much for taking time to do this. This was very helpful. Really appreciate the time you spent with us.
And thanks for inviting me. It was a great conversation with you.